Hey there and welcome to the lesson Overhang Mesh and Line Support of the First Steps course. In this lesson you will learn how to process a part to get a first impression on how it can be manufactured additively. You will analyze the cantilever beam and its orientation to find out which areas need support and evaluate the required support material. Knowing the areas that need support gives you the opportunity to optimize your part and its orientation for additive manufacturing. Okay, as in many cases our input is the internalized cantilever beam geometry, and here it has been moved upwards in that direction to create some distance from the origin or the base surface. And our first step is to mesh the solid body using the body to mesh component. And we will enter the minimum and maximum edge length, and we want the curves to match. So here we have our mesh, plug it into the output container and move on to the next step. So in this step we want to manipulate the orientation of the beam so that you can see the impact the orientation has on the support areas or the areas that need support. So first we want to calculate the center of our beam using the volume component. It outputs the centroid, and then we will rotate our mesh around the center and use the x-axis or the unit x vector as an axis, and we want to get the angle, and here we have an angle in degree. We need to transfer it to radians. Of course you could enter an angle in radians directly, but I prefer working with degrees, and enter it here. And let's blend out the original mesh to take a look at the rotated one. And as you can see here, you can now rotate your mesh around the x-axis. Of course, you could also enter multiple degrees and axis, and then you could rotate it in 3D. But for this simple example, it's fine to just take a look at this one rotation. Okay. The next step is now to calculate the overhang mesh, or to find the overhang mesh and create line supports. So for our rotated final mesh, we want to calculate the overhang mesh with this component, and if you rotate the viewer a bit, you see that all of the below part here does need support. Here you can define the overhang angle, and going with 45 is usually a good value. Okay, and now we can create line supports to support this overhang mesh. And we need to give a spacing for our line supports, and as you can see now, our overhang mesh is supported. If you change the spacing, you'll get more or less of the line supports. Okay, of course these are just curves right now. This is not realistic, and also we want to evaluate how good this part and this orientation is for additive manufacturing, and an indicator is of course the area of the overhang mesh, which we can calculate very easily and plug it into this output container. This is another output. And then for the line supports, to get an idea of how much material would be needed, we can construct pipe curves and calculate the volume of those pipe curves. we need to give this value. Okay, so now you can see that there's a radii applied to our lines. And now we can create pipe meshes from our pipe curves. So if we make these invisible, we now have these pipe meshes and can calculate the volume of those meshes. And now we get a list with the volume for each of those line supports. However, we would like to get an overview, so we will use the component list addition, which will sum up all the values to 1. You can plug it in here and read the total volume, and then plug these into the output. Okay, so now this is not ready to be printed right away. Here the connections have some gaps. This is a first shot or a first indicator, so you can optimize your part for additive manufacturing and get an idea how it works. So now, of course, with this cantilever beam, it's quite easy to find a good orientation, but with other parts it might be a bit harder. And then you can not only manually play around with sliders to change the orientation, you can connect multiple degrees for multiple axes and then variate them in a design exploration or a parameter optimization to find the optimal orientation of your part, to get the smallest possible overhang mesh area, or the smallest volume for these line supports. Using a logic like that, you can optimize the orientation, also the part, for additive manufacturing. In this lesson, you learned how to analyze a part regarding additive manufacturing.